All right, and we are back to the Python Institute, this time in lab number 2.1.6.11, and we are talking about some operators and various expressions. In this lab, we're talking about using numbers, various operators, arithmetic expressions in Python, using the print function and learning to express everyday phenomena in terms of the programming languages. So in this scenario, let's see, your task is to prepare simple code to evaluate the end time of a period of time, given as a number of minutes, which could be arbitrarily large. Start time is given in pair of hours and minutes. And we see here, for example, if an event starts at 12:17 and lasts 59 minutes, it will end at 13:15. So what we're doing basically is we are adding numbers to a clock. And because clocks have 60 minutes and 24 hours, we have to make sure that we maintain ourselves inside of that realm. And then it says, hey, don't worry about imperfections. You may not get this, but we're definitely striving for it to be as close to possible. And then it gives us a suggestion. Use the percentage sign or the modulus operator. So we'll talk about what that actually means shortly. So let's see, it gives us some starting information. So that prompts the end user for the hour. So starting time in hour, prompts the user for the starting time in minutes, and then asks for the event duration in minutes. And we can see here we've got some sample data, 12:17:59, and the expected output should be 13:16. And that keeps going. Let's see right here, for instance, 23:58 and 6:42. So 23, that's 11 p.m. So 11:58 p.m. And then 642 minutes should come out to about 10:40 a.m. in the morning. Same thing with 01 and 29:39 should return back 1 a.m. and 0 minutes. So that's some sample data. Let's see what we can do here. So we start off with hours, minutes, and duration. Now, for example, if we simply, one of the first things we could do is we have minutes, and then we have duration, which is also in minutes. So we could simply print out the duration plus the minutes. So let's try that. Just as an example, print mins plus dura. So here we're taking out the input mins and we're taking the input dura and we are adding those together. And so now if we run it and we go with this right here, let's actually do this right here. So it'll ask us for the starting time in hours. We'll say 12. Starting time in minutes, 17. And again, my browser doesn't like me for some reason. Okay. Starting time at 12, 17 minutes, and a duration of 59. Then we can see that the starting time of 17 minutes plus the duration time of 59 minutes comes out to a total of 76 minutes. Now, technically, that's correct. 17 plus 59 is 76. However, we're also dealing with a clock here, which has a maximum of 60 minutes. So what we need to do is somehow figure out how to calculate if we are going over the 60 minutes. And with that, we can use what's called the modulus operator. So the modulus operator allows us, not just the modulus operator, but two different operators, excuse me. No, that's right, modulus. So the modulus operator allows us to figure out what the difference is between when two numbers are divided. So for instance, when you were a kid, you learned about log division. And it might have been something along the lines of 3 and 7. And so your teacher would say, okay, figure out how many times 3 goes into the number 7. The answer would be 2. And then 3 times 2 is 6, which gives a remainder of 1. And that's what the modulus operator does, or the percent sign function, is it figures out what the remainder is when you divide these numbers together. So for instance, if I took the number 60 and I divided 76, well, how many times does 60 go into 76? Once. Okay, 76 minus 60, there we go, is in fact 16, and that's my remainder, and so that would be my modulus. So what I want to do is, instead of just simply printing the minutes plus the duration, I want to print the minutes plus the duration. Let's put these again in parentheses because I want this to happen in a certain order. Modulus 60. So I then want to essentially divide it by 60 and figure out what the remainder is. And so now if I run it, let's see, 12, 17, and 59. Now I see my return is 16. So the modulus operator helps me figure out how many minutes are left over. All right, so that's getting me one step closer. It's helping me figure out what my actual minute time of the destination, or the end time of this process, would be. So I'm going to actually stream this along. I'm actually going to say mins equals mins plus dura. So we'll get rid of, let's see, move this down. And then print, clear this up a little bit. There we go. So what I'll do is I'll just take minutes, my mins value, and I'll add the duration to it, since it's going to be in minutes already. And then I will do the modulus 60. So I'm basically doing two different lines, except I'm saving my mins value for use at a later point. Oops. Excuse me. So now, just to test it, 12, 17, 59, still turns out 16 minutes. Okay, so that takes care of the minutes of my clock. The next thing I need to do is worry about the hours of my clock. Now again, just like when we were talking about in math class, when you have your 3 divided by 7 divided by 3, how many times does 3 go into 7? Twice. And then minus 6 with a remainder of 1. So we just talked about how to figure this out. Now what we need to do is figure out that portion up there so that we can actually start dividing things, so that when we divide the minutes, we know how many hours to add in to our hours cycle. So we need to figure out how many times we actually divided our number, our 76, by 60. And for that, what we do is, instead of dividing, we use a double division. So let's see. So what we can do for there is we can just simply say hour equals the existing hour. Actually, no, let's not even do that. Let's do print. We'll get into that in just a second. What I want to do is I want to do my mins, and I want to divide it by 60. But if I do it just like this, it's not going to give me a full number, a whole number. And you'll see right here, it actually returns back 1.2666. What I want really is just the number 1. In order to do that, I could use the round command, but if I do simply 2 division signs right there, that's a special function in Python that tells it round it out automatically to only whole numbers. So now if I run it, and again type in the numbers 12, 17, and 59, it tells me I should be at 16 minutes plus 1 hour. All right, so that means it divided by 60. There was one whole number divisible by 60, and therefore that's what it should be. And that number 1 should be added to my hours cycle. So if I actually comment this out, And I'm actually going to say hour equals hour plus, and then the mins with 2 divided by signs, 60. And now just simply print hour. And now we try it. Hour of 12, 17, 59 minutes. And so it tells me my minutes will be 16, my hour will be 13, which is pretty much my expected output. It's just not formatted the way it expected it. So I can go ahead and clean that up. Let's see, hour, comma, because I want to put multiple things together, I'm just going to put commas in between them, and mins, excuse me. And now if I run it, 12, 17, 59, my output is 1376. That's not right. Oh, I missed that. Okay, mins modulus 60. And I noticed that I'm actually got a space right here around my colons. So I'm actually going to add in one more thing. I'm going to add in my sep property. So comma sep equals, and I'll just do a double quote because I don't want any separator in there. So now we run it 12, 17, 59, and I see the final output there is 1316, which means I can actually start commenting out these 2 lines right here. They're not super necessary at this point. One more time just to make sure. And it gives me my 1316. Gives me a couple other sets of test data, so let's go ahead and try these guys right here. 23, 58, and 642, and returns 3440. Well, the 40 is correct. The 34 is not. And when I look at this, let's see, right here, we're actually saying the minutes should be modulus 60. But we're not doing anything like that for the hour. So we're actually saying, hey, you know what? There's only 60 minutes in an hour. But we're never saying that there's only 24 hours in a day. So maybe we need to put a modulus 24 in the hour as well. Let's try that. Since there's 24 hours, let's see, that was, yeah. 34 with 24 hours in a day, so 24 divided by 34, no, 34 divided by 24, however you say that. There's 1 day in there, so 24 minus, that would leave me with 10 hours. And so this is what I want right here. That's kind of nice to know for the duration, but this tells me the end time. And that's really what I'm looking for. So that's what I want right there, is that remainder portion. And so that's right here. I've got my modulus 24. So I'm dividing it by 24 and I'm keeping the remainder. So let's go ahead and give that a shot. So one more time, an hour of 23, 58 minutes, and then 642 minutes total. And it returns back 1040. That's perfect. That's exactly what we were looking at for the expected output. Let's try the last one right here. 0, 1, 29, 39. 0, 1. So that's saying at 1 a.m. and 1 minute. We're running for 29 minutes and 2,939 minutes, which means it will end up at 1 a.m. the following day. And that's perfect. That ran exactly the way we wanted it to. Now, there's a lot of different ways we could have done this. It would have been some combination of, division, either with a single division, with a double division in order to get an integer output, or a single division and as a rounding option, as well as some sort of a modulus function in order to make sure that we only got the portion of the number that we were looking for.